In this video, we're going to continue to learn about solving inequalities. In our previous lesson, we solved inequalities by adding or subtracting whatever the inverse operation was for what was in the original inequality. We're going to continue that same lesson today. This time, our inverse operations are multiplying and dividing. So the multiplication and division properties of equality says that if the number that you're multiplying or dividing by is positive, then you can multiply or divide both sides of the inequality by the same positive number and the statement will still be true. All right? Here's the difference in um, solving inequalities. Is that if you are multiplying or dividing by a negative number, if you're multiplying or dividing by a negative number, you can multiply or divide both sides by a negative number, but you have to reverse the direction of the inequality symbol for the statement to to remain true. Okay, so a greater than or equal to sign becomes a less than or equal to sign, or a less than sign becomes a greater than sign, and so on and so forth. All right, so pause the video and copy. You don't have to copy the examples, but copy this top part into your notes. This is extremely important. All right, so if we do several examples, this is, remember, if it looks like a fraction, that just means that we're dividing the two numbers. So this is C divided by 4. We're dividing by a positive. We're dividing by a positive 4. Even though there's a negative over here, we're still dividing by the positive 4. The inverse operation of division is multiplication. So we're going to multiply by 4, multiply by 4. These 4's cancel out. We're left with C is less than or equal to negative 16. And we keep this the same because we divided by or we multiplied by a positive number. All right. Here we're saying t divided by a negative 4. So once again, even though it's a negative, we're still going to multiply. The inverse operation is still multiplication. Okay, we're still going to multiply by negative 4. Okay, so t, and then because we divided by negative 4, this inequality symbol switches around. So it goes from a greater than to a less than. And 0.3 times negative 4 is negative 1.2. All right? N divided by 6. Multiply both sides by 6. Okay? Once again, we have a negative here, but that doesn't matter because this right here is a positive. Okay? So the 6's cancel out. N is less than or equal to. We keep that inequality symbol because of the fact that it's a positive, and this becomes negative 30. Right? We have we're dividing by a negative 3, so we multiply by negative 3. All right? So the negative 3's cancel out. R is less than negative 2.7. All right? So here we're multiplying. So we're multiplying by 5. So we're going to divide by 5. Divide by 5. 5's cancel out. We're left with A is greater than or equal to 23 over 5, which simplifies down to A is greater than or equal to. We keep the greater than or equal to because we divided by a positive number, and that ends up being 4 and 3/5 or a is greater than or equal to 4.6. Okay? And the way we got that, just as a reminder, if we use a calculator, okay, we took 23 divided by 5 is equal to 4.6. Okay? Okay, so this is backwards. We have had the variable on the right hand side, but just because it's backwards doesn't mean that we do anything differently. We still divide it by negative 24 divided by negative 24. The negatives cancel out, okay, or the 24s cancel out. We have to flip the inequality symbol, okay, and we're left with a b on the right hand side. 192 divided by negative 24 is negative 8. Okay, and if we want to, this is correct. If you want to flip around to where the variable comes first, we can do that. We can say b and negative 8. But then if we flip the inequality symbol, if we flip the inequality um, equation or whatever, we still have to flip it again. In other words, I always say if the small end is towards the variable, then the small end has to continue to stay towards the variable. Or if the big end would be, it just has the relationship still has to stay the same. All right. All right. 6b is greater than or equal to 25 divided by 6 divided by 6. Okay, so we divide it by a positive number. That's a positive 6. So b, so this stays the same, greater than or equal to 25 over 6. b is greater than or equal to, and we use our calculators. So 25 divided by 6, and we end up with 4.16 repeating. So I'm going to say I'm just going to say 4.2, okay? Or it could be 4.117, okay? But um, if you need to round it off to one or two decimal places. I usually specify which one I want you to do that. All right, once again, we're divided by negative 17, divided by negative 17. Because we're dividing by a negative, this flips around. We're left with a b. 85 divided by 17 negative is negative 5. Okay? Yep. Okay? And so um, if we if we did one, if we did another one, suppose we did one that we just said uh, negative 3x is greater than or equal to um, negative 144. Okay, if we did that, now this negative here doesn't matter. What matters is that we're dividing by a negative 3 divided by a negative 3. Okay, the 3's cancel out. X is less than or equal to negative divided by negative is a positive. 144 divided by 3 is equal to 48. Okay, so that's all there is to it. Make sure that you ask for questions if you don't understand something. We'll talk to y'all later.